Welcome back to another explainer, everyone. Today, we're unpacking the absolute masterclass in engineering behind the newly released open-weight Qwen3 model. Now, if you've been tracking the rapid evolution of AI, you already know that finding the perfect balance between raw reasoning performance and sheer computational efficiency is basically the holy grail. Well, based on the data we're looking at today, it looks like we've just taken a massive leap forward.
So, let's dive into a fundamental problem we're always running into in AI. Traditionally, it's a trade-off, right? Models either give you quick, shallow answers or slow, complex reasoning, but rarely both at the same time. You usually have to pick your poison. Do you want a lightning-fast chatbot for casual back and forth, or do you need a heavy, slow-burning reasoning model to crank through complex math? But what if you literally didn't have to choose anymore? What if a single system could seamlessly handle both?
Here's our roadmap for today. We'll meet the Qwen3 model, look inside its MoE engine, go over the pre-training curriculum, see how you can actually control this AI's brain, and finally, check out how it's completely dominating the benchmarks.
Okay, Section 1. Meet the Qwen3 model and its path to AGI.
Released completely open-weight under the Apache 2.0 license, Qwen3's real game-changer is its unified framework. By combining these two modes under one roof, it completely ditches that annoying need to constantly toggle between a chat-optimized model and a dedicated reasoning model. It actually has a thinking mode for those brutal physics problems and a non-thinking mode for when you just need a quick summary. It adapts precisely to whatever task you throw at it.
Moving right along to Section 2, inside the MoE engine and its surgical efficiency.
To really get how this AI thinks, we've got to talk scale. 235 billion. That is the total number of parameters in the flagship Qwen3-235-A22B model. Now, at first glance, that sounds incredibly heavy and wildly expensive to run. You might be sitting there wondering how anyone could possibly use this without a multi-million-dollar supercomputer humming in their basement.
But here's where the mixture of experts, or MoE design, works its absolute magic. Out of the 128 total experts built into the model, Qwen3 only fires up 8 of them per token. So it holds 235 billion parameters of total knowledge in its head, but it is surgically efficient. It only pulls the exact 22 billion parameters it actually needs to answer your specific prompt.
And they didn't just make it big. They made it incredibly stable across a massive 128,000 context window using some really clever architectural tweaks. First, no shared experts literally forces different parts of the model to deeply specialize. Then they introduced QK-norm, which acts like a stabilizing filter so the model doesn't get confused, dropping perplexity by 20 to 30% on huge documents. And for raw speed, dual-chunked attention breaks massive text into overlapping digestible bytes, boosting throughput by 1.6 times without losing an ounce of accuracy.
All right, part 3, the pre-training curriculum and building the AI brain.
You know, an engine this perfectly engineered is basically a paperweight without premium fuel. So how exactly did they teach it? Volume and diversity. The model devoured an astonishing 36 trillion tokens of data, covering 119 different languages and dialects. But they didn't just lazily scrape the internet. In a brilliant bit of AI inception, they used older models like Qwen 2.5 math encoder to synthesize and validate trillions of tokens of complex math to teach the new model.
And they were super intentional about how they fed it all this data. Qwen engineers used a highly structured 3-stage curriculum. In step 1, they poured in over 30 trillion tokens just to build a massive foundation of general knowledge. Then, in step 2, they shifted gears, focusing on about 5 trillion extremely high-quality STEM and coding tokens to teach it deep reasoning. Finally, in step 3, they stretched its brain, extending sequences up to nearly 33,000 tokens to ensure it could process massive, book-length prompts without hallucinating.
Let's move into Section 4, controlling the AI brain through post-training and distillation.
Once the model absorbed all that core knowledge from pre-training, the developers used a really sophisticated pipeline to teach it how to explicitly control its own thought process. The secret sauce here is GRPO, or Group Relative Policy Optimization. Using challenging query verifier pairs, this reinforcement learning technique literally taught the model how to pause and reason through hard problems before just blurting out an answer. The results? Absolutely wild. In merely 170 training steps, its score on complex math benchmarks skyrocketed from 70.1 up to 85.1. It learned that taking its time and building a chain of thought yields vastly better results.
This right here is a massive philosophical shift in open source AI. Think about Claude 4, right? The extended thinking is mostly gated internally. The AI hides its reasoning from you and just gives you a summary behind the scenes. Qwen3 hands you the steering wheel. You have explicit user control. You can literally just type /think or /nothink right in your prompt, setting a dynamic, user-defined compute budget that dictates exactly how much processing power it's allowed to spend pondering your question.
Finally, Section 5, dominating the benchmarks and letting the numbers speak. All of this engineering and explicit control sounds incredible in theory, but let's see how it actually performs against the heavyweights. We're matching up the Qwen3 base model directly against DeepSeek v3. Look at how Qwen3 punches way above its weight class. Despite using about 15 billion fewer active parameters per token, it boasts a massive lead. It scores 87.4 on MMLU Redux for general knowledge, completely dominates in math at 71.84, and leads the Eval Plus coding benchmarks by an astonishing margin. Efficiency is actually enhancing performance here, not dragging it down. And if you ever doubted why having an explicit thinking mode matters so much, just look at this. When faced with a brutal math test like the AME 2025 benchmark, the non-thinking mode, relying purely on its fast reflexes, scores a meager 24.7. But flip that switch. Let the model map out a chain of thought, and accuracy jumps to a staggering 81.5. That is the true power of the dual engine at work.
But wait, it actually gets more fascinating. You'd assume the thinking mode would just sweep everything, right? Well, not quite. If you look at the Arena Hard Alignment benchmark, the non-thinking mode actually scored slightly higher, 96.1 compared to 95.6. This perfectly validates their unified framework approach. It proves that you don't lose your incredibly sharp conversational AI just because you gave it the ability to be a slow-thinking math genius. Drawing right from the research, the takeaway is undeniably clear. We now have a single, highly efficient, unified model that rivals proprietary giants. From dominating Codeforce's ratings to holding state-of-the-art status across 119 languages, Qwen3 proves for sure that open-weight AI can achieve extreme scale and pinpoint efficiency all at once. As we wrap up this explainer, I'll leave you with this thought. We are officially entering an era where the black box of AI reasoning is finally being opened up to the user. When the power to dynamically balance lightning-fast speed and deep, multi-step reasoning is completely in your hands. What impossible problems are you going to solve next? Thanks so much for joining me today, and keep exploring.